Hi everyone. Now we are going to discuss about the synthesis and reactions of thiophene. Let us see the structure of thiophene first. This is the structure of thiophene. So this thiophene is a 5-member ring with one heteroatom. The heteroatom will be sulfur. What is this thiophene? Actually, this thiophene is a colorless liquid. It is insoluble in water but miscible with the other organic solvents. So this is the structure of thiophene, which is having the molecular formula of C4H4S. So the numbering will be, so sulfur is present, so we have to give the numbering sulfur first, then we can give either clockwise direction or anti-clockwise direction. So this is the numbering 1, 2, 3, 4, 5. This is the numbering of thiophene. So how will you prepare this thiophene? So thiophene can be prepared by treating N-butane with the sulfur at a temperature of 600 degrees Celsius, that is vapor phase, which will give the product thiophene with the elimination of hydrogen sulfide. So when we are treating the N-butane, that is CH3, CH2, CH3 with the 4 sulfur, will give the thiophene with the elimination of hydrogen sulfide. Then it can also be prepared by treating sodium succinate, that is CH2COONA, CH2COONA, and treatment with the phosphorus trisulfide, that is P2S3, will give thiophene. Let us see the reactions of thiophene. This thiophene first reaction will be reduction. Thiophene on reduction with the palladium catalyst, it will give the tetrahydrothiophene. That is, here double bond is present, 2 double bonds are present, that will be becoming saturated. So thiophene on reduction with the palladium catalyst, it will give tetrahydrothiophene. The same thiophene on oxidation, here S is present, so it will be converted into SO2. That is, sulfones will be formed. Sulfur will be oxidized to give SO2. Sulfones will be formed. Then thiophene nitration reaction, thiophene on treatment with the nitric acid in presence of acetic anhydride, it will give the 2-nitrothiophene. The electrophilic substitution reactions, most of the electrophilic substitution reactions will be carried down in the second position of thiophene. So this thiophene on nitration in presence of acetic anhydride, it will give 2-nitrothiophene. The same thiophene on treatment with the sulfuric acid. So if you are treating with the H2SO4, it will give thiophene 2-sulfonic acid. Thiophene 2-sulfonic acid will be formed on treatment with the sulfuric acid. So next one will be, as we know, the electrophilic substitution reactions such as nitration, sulfonation, halogenation, acetylation and alkylation. Here next reaction will be chlorination. So thiophene on chlorination, it will give 2-chloro. So thiophene will react with the Cl2, it will give 2-chlorothiophene with the elimination of hydrogen chloride. Similarly, if we are treating thiophene with the bromine, HBr will be eliminated to give 2-bromothiophene. Then next reaction will be acetylation, that is thiophene on treatment with the acetic anhydride, that is CH3CO twice O in presence of phosphoric acid, it will give 2-acetyl, that is CH3CO twice will be present. So one COCH3 will be added to the second position. The remaining COCH3 and one more O, that will be eliminated as acetic acid. Reactions of thiophene. So let us see the recap of this reactions. That is, thiophene on reduction with the palladium catalyst, it will give tetrahydrothiophene, and thiophene on oxidation, it will give sulfone. Similarly, the electrophilic substitution reaction such as nitration, it will give 2-nitrothiophene, and thiophene on sulfonation, it will give thiophene 2-sulfonic acid. On chlorination, that is on treatment with the chlorine, it will give 2-chlorothiophene, and on bromination it will give 2-bromo-thiophene. And acetylation, that is on treatment with the acetyl anhydride, it will give 2-acetyl-thiophene. This is the reactions of this thiophene. This is about the synthesis and reactions of thiophene.